Dividing polynomials using synthetic division. This is our example. 10x squared minus 15x minus 20 is our dividend, and x minus 5 is our divisor. Now, to divide polynomials using synthetic division, we are going to put the terms here, or the numbers, in these two boxes. So for this bigger box, we are going to put all the numerical coefficients of our given dividend. Again, let us rewrite here our dividend. We have 10x squared minus 15x minus 20. Make sure that the terms are arranged from the highest or from the biggest exponent to the smallest exponent, and the last term will be the constant. And then we will take the different numerical coefficients. So for 10x squared, the numerical coefficient is positive 10. Put here positive 10. This will be followed by negative 15. So put here negative 15. And the constant is negative 20. So we will put here negative 20. And then for the number here on the smaller box, this will be the opposite sign of the constant of our divisor. Our divisor is x minus 5. Its constant is negative 5. But the opposite sign of negative 5 is positive 5. So we will put here positive 5. And then bring down positive 10. So bring down positive 10 here. And multiply 5 and positive 10. 5 times 10. So 5 times 10, that is positive 50. Put positive 50 here on the second column. We will have here positive 50. And then perform addition. Negative 15 plus positive 50. This is equal to positive 35. Next, multiply positive 35 and 5. We will have here positive 35 multiplied by 5. So 5 times positive 35, this will be equal to positive 175. Negative 20 plus positive 175, this will be positive 155. Okay, so these are now the numerical coefficient, the constant, and the remainder. Now, let us determine what will be the highest exponent. So to find for the highest exponent that we will put here for 10, we will divide x squared. So divide x squared and x. X squared divided by x is x. So x here will be the variable of positive 10. We will have here 10 times x plus, since this is already x, positive 35 now will be our constant. 10x plus 35 is already our quotient. And positive 155 here, this is the remainder. So we have here the remainder. So we will add here the remainder, which is positive 155, and divide this by the divisor, which is x minus 5. Therefore, 10x plus 35 plus 155 divided by x minus 5 is our final answer. Dividing polynomials using synthetic division. We have here 12x cubed minus 21x squared plus 25x minus 10 as our dividend, and 4x minus 3 as our divisor. So to divide polynomials using synthetic division, we will have here two boxes, the bigger box and the smaller box. Now, the ones that we will put here, or the numbers that we will put on the bigger box, will be the numerical coefficients of our dividend. So we have here 12x cubed minus 21x squared plus 25x minus 10. The numerical coefficients here, make sure that the terms are arranged in consecutive orders. So from the highest here is 3, the highest exponent. This is followed by positive 2 and positive 1. They are arranged in consecutive orders. Let us now get the numerical coefficients. Our first coefficient is positive 12. This is followed by negative 21. And then we have positive 25. And the last will be the constant, which is negative 10. The number here on the smaller box will be from the divisor. Our divisor is 4x minus 3. But remember, it should be of the form x minus r. Again, our divisor, 4x minus 3. So to make this of the form x minus r, we have to separate 4. So 4 and then open parenthesis x. So 4 multiplied by x, that is still equal to 4x. And then this will be minus 3 over 4. Now, why negative 3 over 4? Since 4 multiplied by negative 3 over 4 is still equal to negative 3. So this is still equal to 4x minus 3. Okay, we can get here the number that we will put, since the constant is negative 3 over 4, the number here will be the opposite sign. So the opposite sign of negative 3 over 4 will be positive 3 over 4. Bring down positive 12. And then multiply 3 over 4 and 12. 3 over 4 multiplied by 12. This will give us positive 9. And perform addition. Negative 21 plus positive 9, this is negative 12. And multiply negative 12 and positive 3 over 4. So positive 3 over 4 multiplied by negative 12. This will give us negative 9. Put negative 9 here. 25 plus negative 9, this is positive 16. And multiply positive 3 over 4 to positive 16. So 3 over 4 multiplied by positive 16. This will give us, okay, so positive 3 over 4 multiplied by positive 16, this will give us positive 12. Negative 10 plus positive 12, this is positive 2. And to find here the variable of 12, we are going to divide the highest exponent, which is x cubed, divide that by the exponent of our divisor, which is x. So x cubed divided by x, this will be equal to x squared. This will be our variable for the first term. We will have here 12 x squared minus 12x. So since this is already x, positive 16 will be our constant. This will be plus 16. Positive 2 here will be our remainder. Now take note, we have here 4 as the numerical coefficient of x. So since we separated it, we have first to divide the quotient by 4. So this will be divided by 4. Our quotient now will be 12x squared divided by 4. This is 3x squared. And negative 12x divided by 4, negative 3x. Positive 16 divided by 4, positive 4. And you add this by the remainder. Our remainder is positive 2. And the remainder will be divided by the divisor, which is 4x minus 3. Therefore, 3x squared minus 3x plus 4 plus 2 divided by 4x minus 3 is our final answer. Dividing polynomials by synthetic division. If we will be dividing polynomials by a trinomial, meaning we have here 3 terms, this is what we are going to do. So first, draw a figure like this, and then let us start with our dividend. Get all the numerical coefficients of our dividend. So this is our dividend. The first coefficient is positive 6. Put positive 6 here. This is followed by negative 46. Okay, we have here negative 46. And then positive 34. negative 46, followed by positive 5, and positive 17. Okay, let us extend the yellow portion so that it will cover positive 17. Afterwards, we are going to get the coefficients or the numbers from our divisors. So we have three terms here. We will start from the constant. So we will get the opposite sign. Since this is positive 7, its opposite sign will be negative. So this will be negative 7. And negative 8, its opposite sign will be positive 8. Put positive 8 here. And next, bring down positive 6. Bring down positive 6 up to the bottom. After bringing it down, write positive 6 here. This will be our first term for the quotient. And then this will be followed by negative 46. Bring down negative 46, but only up to this level. Write negative 46 here. And then we are going to multiply. Start multiplying. The first numbers that we will multiply will be 8 and 6. 8 multiplied by 6. 8 multiplied by 6, this is positive 48. Write positive 48 here. And perform addition. Negative 46 plus positive 48, this is positive 2. Next, multiply negative 7 and positive 6. Negative 7, multiply this. Negative 7 multiplied by positive 6. This will be here, negative 7 multiplied by positive 6. Negative 7 times positive 6, that is negative 42. We are going to put it here below 34, negative 42. And then we are going to perform also the addition. 34 plus negative 42, this is negative 8. Next, we are going to multiply positive 8 again, but this time we are going to multiply it with positive 2. 8 multiplied by positive 2. 8 times 2, that is positive 16. We will put here positive 16. And then perform addition. Negative 8 plus positive 16, that is equal to positive 8. And then multiply again negative 7. This time multiply it with positive 2. Negative 7, multiply this by positive 2. Negative 7 times positive 2, that is negative 14. We will write negative 14 here. And then perform addition. Negative 14 plus, or rather negative 46 plus negative 14, that will be equal to negative 60. And then multiply positive 8 again. Multiply that positive 8 to positive 8. We will have here 8 times 8. 8 times 8, that is positive 64. Put positive 64 below negative 60. Negative 60 plus positive 64, that will be positive 4. And then multiply positive 7 again. Use positive 7 again, or rather negative 7. Negative 7 multiplied by positive 8. Negative 7 multiplied by positive 8, that will be negative 56. And positive 5 plus negative 56, that is negative 51. And multiply positive 8 again. Use positive 8 again. This time we will multiply positive 8 to positive 4. 8 times 4, that is equal to 32. Put 32 here. And then perform addition. Negative 51 plus positive 32, that will be negative 19. And then multiply negative 7. Negative 7 multiplied by positive 4. Negative 7 multiplied by positive 4, that is negative 28. And then positive 17 plus negative 28, that will be negative 11. And just bring down negative 11. We have the numerical coefficient for our quotients. Okay, we may erase this one now. Now to find for the variables, the first variable will start from 6. So to do that, we will just divide here x raised to 5, since that is the highest term, x raised to 5, and then divide that by our highest term here from the divisor, x squared. X raised to 5 divided by x squared, this is x raised to 3. So meaning to say, for the quotient here, our first term will be x raised to 3. We will put it here beside 6. We will have here 6x raised to 3. And then this will be followed by x raised to 2, and then x. So 4 here will be the constant already. And then we will separate this one. Negative 19, we will put here x, and negative 11 is the constant. Negative 19x and negative 11, they are now our remainder. Our quotient now will be 6x cubed plus 2x squared plus 8x plus 4. And the remainder, this will be plus negative 19x minus 11, and divide this by the divisor. Our divisor will be x squared minus 8x plus positive 7. And this is now our final answer.